Now let's take a look at installing Red Hat Enterprise Linux on our server across the network using a RAID5 base configuration. Again, this is another certification objective, the ability to define and allocate RAID5 partitions to a RAID5 set, which you can then overlay a file system on. So our system's booting up. It'll enumerate the 3 connected hard drives. Now for RAID5 support, you need 3 hard disks. However, Red Hat Enterprise Linux supports RAID 5, 0, 1, as well as linear and 4. Now it's easier to allocate RAID 5 partitions with a graphical interface, although it is possible to do so with the text-based interface. So with that said, we won't type Linux text, for example. We'll simply indicate Linux ask method. We have booted with the boot ISO image, which is a network boot image, which will allow us to connect to the HTTP published share and install across the wire. So we're installing across the network as well as provisioning a RAID 5 volume. Also, one other caveat or one other note is that you're unable to assign the boot mount point to a RAID 5 partition. You can, however, assign boot /boot, which houses the Linux kernel, amongst other things such as the grub files, to a RAID 1 or mirrored partition. So keep that in mind. So when we define our partitions, we'll either have to create 2 RAID sets, one mirrored for the boot partition and one RAID 5 for everything else, or create a boot mount point on a non-RAIDed partition. That's just a limitation built into Red Hat Enterprise Linux to prevent administrators from clobbering inadvertently their boot mount point. So that's let's move forward with our installation. The various drivers are loading. Again, this is a pretty quick system, so it cycles through the boot up initialization process very rapidly as opposed to the VMware instance. Let's tab and select OK for English for the installation process and US for the type of keyboard that we're using. And here are the options we saw during the VMware installation. Again, we'll be able to select from local, hard drive, NFS, FTP, and HTTP. Since we have the image out on the HTTP Apache server, we'll simply select HTTP. IPv4 and v6 support is enabled by are enabled by default using DHCP. And now we'll specify the IP address of the server, followed by the location of the share, which is RH5 I386. Once you see that the stage 2 image has been retrieved or is in the process of being retrieved, that tells you that your client, in this case the PowerEdge server, has made a connection to the Apache-based server, because that stage 2 image file does not exist on the local bootable CD-ROM, which was created with the boot.iso image located in the images subdirectory beneath the root of the DVD-ROM or first CD-ROM of the 5 for Red Hat Enterprise Linux version 5, in this case 5.1, major version 5. So now we're launching a graphical installation. Here's the opening menu, and of course the files have to be copied across the wire. And we're using a USB laser mouse. Let's just move forward into the installation. Again, it's easier to configure RAID 5 or any of the RAID levels or even logical volume management using the graphical interface than it is to do so with the text-based interface, but both are possible. Pretty much everything you can do in one interface you can do in the other. The graphical interface simply presents it in a much more readable fashion. So we'll skip entering the installation number, because again, our intent and purpose is to illustrate how to configure RAID 5 and how to install across the network using the boot ISO image. Again, you can boot your system with the DVD-ROM or the first CD-ROM, and then indicate Linux space ask method to have the installer prompt you for where the binary files should be copied from. So we're going to install our Enterprise Linux server. We won't upgrade the existing installation. As you can tell, it has detected the prior installation. Our first installation was performed on this box. Now here are 3 hard drives. We can elect to remove all of the Linux partitions or all of the partitions altogether. It's entirely up to us, but we want a custom partitioning scheme. You click the drop box, you'll see use free space, remove all partitions, remove Linux partitions, or create a custom layout altogether. There's also an advanced storage configuration which allows you to connect to iSCSI targets. iSCSI is a hot networking protocol, or one of the popular cost-effective ways of connecting to remote storage across the network wire. So keep that in mind if you do have iSCSI targets out there. Let's click on Next to move forward in the installation and remove the existing partition layout and set up a new partition layout based on RAID. So in the installer, you have the ability to create basic partitions as well as to manipulate them by editing, deleting, resetting them, so on and so forth. If you reset the partition table to its original state, then we'll see momentarily what it does. And we also have the ability to control RAID as well as LVM. So here are the various partitions based on logical volume management. These are the logical volume groups, or the LVM groups that are on the system. One group, group 0, includes 2 logical volumes. We should remove those logical volumes and then create RAID5 based file systems. Let's delete each of these logical volumes. As well as the volume group, you must delete the contained logical volumes before you may delete the volume groups. And here's another volume group 00. And we'll get rid of the swap partition as well. So basically cleaning up manually in order to lay out RAID 5. In your case, you may opt to use free space. Just provision enough partitions, at least 3 for RAID 5, from your free space. And ideally, the 3 partitions should be spread across 3 disks, 3 physical disks, as opposed to 1 physical disk, although you can do it if it's on 1 physical disk. And we can't delete that other partition because it's a part of a volume group, so we need to get rid of the volume group. So as you can see, there are quite a few items here for us to manipulate. Let's try to delete this volume group, which will remove any trace of LVM altogether. And now LVM's gone. So each drive has been expanded. Let's collapse them. Here are the 3 drives, SDA, SDB, and SDC. We'll quickly peruse each of the drives to be sure that there are no partitions. Here we see SDC1, which is LVM. We should delete it. We want to get to a state where we have raw partitions, or raw drives with no partitions. So for example, SDC now has free space. That's raw space which can be assigned to anything, including RAID, LVM, ext3, or any supported file system. SDB now has free raw space, and SDA has free space, but it also has an LVM physical volume, which we'll delete. So now all 3 hard drives have free space, occupying the 36 gigs, roughly 36 gigs per drive. So we have 3 36-gig hard drives. They're physically distinct. This isn't VMware. This is an actual system. And now we can set up our RAID environment. Now to set up RAID, you need to have your partitions set up in such a way so that you can then move on to the RAID section. You create a software RAID partition out of free space that you have, and once those software RAID partitions are in place for the desired level, such as RAID 5, you then create a RAID device. Notice that the interface grays out creating a RAID device until you've created 1 or more RAID partitions. By 1 or more, we mean enough to support the various levels of RAID. For example, for RAID 0, 1 or more will suffice. For RAID 1, 2 or more will suffice. And for RAID 5, 3 or more will suffice. So to create a software RAID partition, click OK. and you'll see the different disks that are available. You can include all of them. You can set a size for the software RAID partition up to the maximum size for the desired RAID type. Now, by default, all drives are considered to be a part of the software RAID partition, and a default size of 100 megabytes is suggested. Of course, this can be altered. Let's say we wanted a RAID software partition of perhaps 50 gigabytes or 50,000 megabytes. We'll go ahead and specify 50, and this would give us an estimate, 1,000 megabytes, and this would be roughly 50 gigabytes. That tells you partitions of software must be constrained to a single drive. This is done by selecting. Now, by default, all drives are considered candidates. So in this case, we have to deselect 2 of the 3 drives and then define a given size out of the drive that we've specified, or you can fill it to the maximum allowable size. So it's up to you. Either you fill to the full size of the drive, or you set a fixed size. Now, I prefer to go with fixed size because that leaves us space to create the boot partition outside of this RAID partition. So let's go ahead and indicate 20 gigabytes. $20,000 megabytes as a fixed size from the first disk for software RAID. And what you'll now see for the first disk is a software RAID partition with free space. So there's free space that we can use to create a boot partition. And we can do so at any time by clicking on New. And sometimes it helps if you even do it at the beginning of the disk. So let's go ahead and remove this. Although it would still work, it still would boot. And you'll see a graphical layout up top as to how each disk is being used. So for SDA, we'll go ahead and click on New. Any order is fine, especially for modern systems. From the drop list, you'll see the different common mount points, so we'll indicate boot, ext3. By default, again, all of the drives are selected, but we want boot to be constrained to 1 disk, and we want boot to be 100 megabytes. We can also force it to be a primary partition. Otherwise, the disk druid utility will move the partitions around, making some logical whenever necessary. So we've got boot taken care of. Now let's move on to the RAID partition again. So back to RAID. This brings up the RAID wizard. We'll create a software RAID partition. By default, all 3 candidate drives, or all n number of drives, are selected. We'll deselect, indicate a size of 20,000 megabytes. This will leave us space to create other partitions. It doesn't need to be a primary partition. Now we've got software RAID 20,000 megabytes on the first disk. Now, if we're going to create a RAID 5 set or striping with parity set, all of the partitions should be of at least the same size. Some may be larger, but they must be at least the same size. So you have to create the partitions to the lowest common denominator. So with SDB, we'll go ahead and launch RAID again, create a software RAID partition, deselect SDA as well as SDC, and define the size to be 20,000 again. Click on OK. This will create software RAID on the second drive. We still have got space on the first disk or on a different disk, second or third, for swap space, which we'll look at momentarily. So now we've got 2. We could go ahead and create a mirrored RAID set. That would certainly work. However, our intent is to create a RAID 5 set, which is striping with parity, which offers performance enhances plus greater size allocation. So we lose less storage when we allocate using RAID 5 as opposed to RAID 1, or striping with parity as opposed to mirroring. Let's go ahead and click on RAID again. Notice we now have the ability to create a RAID device because we currently have 2 software RAID partitions. However, we want a third. So we'll go ahead and click on Create a Software RAID Partition, then OK. And we'll make it out of SDC by deselecting SDA and B and setting its size to 20,000 megabytes. Again, there are options to fill space up to a certain size, allowing the partition to grow, or fill to the maximum allowable size. But be careful when using those options when multiple partitions are configured similarly, because they'll compete for the remaining space on the disk. This doesn't need to be a primary partition. And now we've got 3 software RAID partitions plus free space. So to create that RAID device, which will be beneath or created beneath the dev tree as MD0 or beginning with MD0, click on RAID once more, and the second option is auto-selected, create a RAID device. The default device, again, will be created beneath the dev tree. The dev tree is a special directory within Linux and Unix systems used to house drivers or modules, means of accessing hardware devices connected to your Linux system. We'll click on OK. And here's another option, by the way, clone a drive to create a RAID device. You can actually clone an existing drive to create a device. So if there's already a RAID set up on a drive that you'd like to clone or duplicate to another drive, for example, we've got 3 disks, SDA, B, and C. If we've set up SDA and we'd like SD, B, and C to follow, then just simply select clone a drive, select the source drive, the target drive, and the partition table will be duplicated to the target drive, so that you don't have to repeat the steps of inserting the number of megabytes and whether or not it should be global and so on and so forth. So we'll create a RAID device, and the mount point for this RAID device will be the root file system. However, there are other mount points, the common mount points, opt, back through boot, but boot we've already allocated. We'll create this 20 gigabyte space for root, and its file system can be any of the following: ext3, physical volume to then be assigned to logical volume management, ext2, swap, vfat. The RAID device will be MD0, however, you can select any other number. It defaults to MD0, that's the first device. The RAID level needs to be indicated. Here are the supported types: 0, 1, 5, and 6. With the common ones being 0, 1, and 5. RAID 0 offers no redundancy, but it does offer fast access to disks. It's a way of creating volume sets, for those of you familiar with volume sets from Solaris or from Windows NT 2000, 2003, etc. So RAID 0 is analogous or similar to volume sets in other operating systems, where it allows you to aggregate storage and present that storage as one large unit or one aggregate, consequently writing the data sequentially to the disks that are part of the volume set. However, if one of the disks in the set fails, you lose your data. So use RAID 0 when you need speed and the data is not as important, perhaps you back it up often. RAID 1 is mirroring. RAID 1 requires 2 identical partitions, or 2 identical disk sizes. It's used to copy data from one to the other or to perform multiple writes. So when you issue a write, let's say you've saved the text file gets written to both disks, and in the event of failure of one of the disks, let's say disk 1 fails of the 2-disk set, disk 2 will maintain a copy and be accessible unbeknownst to the user. So this is truly a redundant way of doing business. RAID 5 is in between RAID 0 and RAID 1 in that it provides fast access but also provides redundancy up to 1 disk failure. So in a RAID 5 set, if you've got at least 3 disks, which is a requirement, if one fails, your system will operate in a degraded fashion, but your data will still be available, and your performance will be restored once you've replaced the failed disk and the RAID process has rebuilt the parity information. But with RAID 5, the data is striped across all 3 disks, or at least 3 disks, striped across all the disks in the set, and parity information is maintained in the event that one disk fails. The RAID set will still be able to service your clients, albeit in a degraded fashion. So RAID 5 offers the best of RAID 0 and RAID 1 without sacrificing too much storage or too much performance. We'll go ahead and select RAID 5. These are the partitions, and they are physical disks indicated by the alpha values A, B, and C that will be used. SDA2, the second partition, SDB1, SDC1. And you can also assign spares. So if we had another partition, another software RAID partition, we could include it and assign it as a spare. In the event that one of the disks fails, the spare will be used to immediately rebuild the parity information so that performance isn't degraded for too long a time. Let's click on OK. And this will create momentarily our software RAID device located at dev MD0, and that's where the root file system will be mounted. Here we see RAID devices, a new container which is expanded, which contains dev MD0. The file system which will be overlaid is exe3, and notice the size is 40 gigabytes. Again, with RAID 5, you lose the storage of one component, not half the storage as you do in the case of RAID 1. So in this case, we benefit because we get more of the storage. So we've allocated 60 gigs, we've only lost 20. And below, we still have extra storage to create additional partitions. So if we scroll down, we'll see that on SDA, we've got boot, software RAID, and free space. Now, it's a good idea to store your swap on a different drive to increase performance. In other words, to allow your system to initiate I/O to as many distinct disks as possible. So with that said, we can use either SDB or SDC to store our swap. So if we navigate to SDB and create a new partition, you always need swap. Whether or not your OS uses it is a separate issue. We ignore the mount point section as we've done in the text-based installation, navigate to swap, which voids this section, deselect the disks that are not to be included or are not candidates, and since this system has half a gig of memory, we'll make swap 1024 megabytes or a gigabyte. Doesn't need to be a primary partition, and now we've got swap allocated on SDB2. And when the system comes up, it will have at least a gigabyte worth of swap. If you wanted to create more swap, let's say another gigabyte on SDBC, or SDC that is, as SDC2, then go ahead again and indicate type swap, deselect the drives that should not be candidates, and set the size to something that makes sense. It doesn't have to be identical to the other swap partition. But in this case, just to make it simple, we'll make it the same. So now we've got two swap partitions for a total of 2048 megabytes, or 2 gigabytes of swap, and we still have free space. So we've got a RAID device, MD0. We can create additional RAID devices, because if you notice in the top section, the graphical layout tells us what storage is available to us, how the storage is being used per disk. Each disk is 36 gigabytes, but we're using roughly 60% of each disk with free space to spare. So if we wanted to make boot, for example, RAID, or to install it on a RAID partition, we could create two new software RAID partitions, mirror them, and then mount boot to those two partitions. And it would create a new device, dev MD1, for example, instead of dev MD0. But it's not necessary. So dev MD0 will serve as our root container. Boot will be on dev SDA1, and it will not be redundant. SDA2 is swap. SDB1 is software RAID. SDB2 is swap. And SDC1 is RAID. SDC2 is swap, with free space to spare. Now, after you've created your software RAID device, such as DevMD0, you have the ability still to include this device in logical volume management. So we could create a logical volume out of one or more RAIDed devices. It's entirely up to you, which would create an additional layer of abstraction. So the kernel would take care of RAIDing or striping the data across the three disks, and then the kernel will also take care of the logical volume management, the management of the storage in a dynamic fashion, such that we can grow, decrease, and so on the logical volumes. Once your storage is set and ready to move on, click on Next. Again, we've allocated 40 gigabytes RAID 5, or 16 gigabytes, which renders 40 gigabytes RAID 5, which is more than enough storage for all of our mount points, so we don't need a distinct mount point. So when you're done, click on Next. It tells us the Grub bootloader will be installed on DevSDA, which is the first hard drive. And the bootable partition, DevMD0, will be set. This will be the default partition. If we'd like to assign a bootloader password, now's our time to indicate as such, to prevent unauthorized access. We'll click on OK. If you need advanced bootloader options, such as parameters to pass into the bootloader, by clicking on Check, another form will be made available. And here we have the ability to assign the IP address dynamically, statically. We'll leave it at dynamic for now because we'll be reinstalling the server. The server name, instead of deb1, let's set it to be Linux CBT serv2. This is the second server. And again, DHCP will take care of the default gateway, the primary DNS, and the secondary DNS. In our prior installation, we saw that when we assigned the address statically, it forced us to specify the gateway DNS, primary and secondary DNSs manually. But with DHCP for IPv4 and v6, everything's grayed out, as those settings will be downloaded from the server. Now let's continue with the fully qualified name. We left out the domain part, and we'll click on next, and this will take us to the time zone information. The system clock does not use UTC, and it tells you when you hover over it the purpose. This is another reason for using the graphical environment. If you want to be able to switch between normal and daylight savings time, then set your system clock to use UTC and allow the operating system to modify it accordingly. Let's set a password for administrator and proceed with the installation. We'll click on next, and this will retrieve installation information. We'll ignore these groups because again we'll be reinstalling the system momentarily. Again, our intent here is to focus on RAID 5 deployment for the root file system, and later on we'll be looking at logical volume management. So as far as partitioning is concerned, we've looked at the default layout, which provides a very large root file system and a swap partition. We've also looked at custom partitioning, where we laid out separate var, home, swap, root, and boot mount points on different file systems using the VMware instance. And now we're looking at software RAID, RAID 5 to be exact, which allows us to achieve greater performance by striping the data, the reads and the writes, across multiple disks, and also to improve our redundancy by making the data available in the event of failure of one of the disks. Not one or more, but one. RAID 5 can sustain the failure of one disk, one and only one disk. If you need to be able to sustain the failure of more than one disk, then you'll want to look at perhaps RAID 10, which will allow you to sustain two disks or more, depending on the way you've configured the RAID 10 set. But as far as RAID 5 is concerned, one disk failure will be sustained. And for most environments, the failure of one disk, or the ability to sustain the failure of one disk, is sufficient, as usually disks don't fail that often. So dependencies are being resolved, and momentarily we'll be off to the copy process, which will get through quickly, and once the system's up and running, we'll enumerate the file systems to be sure that software RAID is in place. Just like with the text-based installation, it tells us that beneath the root directory, a file named install.log will be created, as well as anaconda-ks.cfg. Again, for subsequent installations, if you want to use Kickstart, rename anaconda-ks.cfg to ks.cfg. Publish this file on an accessible location like a floppy disk, CD-ROM, or out on an HTTP server, and then start your installation using either the boot.iso, which ultimately allows you to connect to a network source, or using the DVD or 1 of 5 from the CD set, and then specify Linux ks equals and the location of the ks.cfg file, and that will allow you to kickstart the installation and hopefully take you through a totally hands-free installation. And by hopefully we mean if all of the options have been specified, all of the answers to the questions that are going to come up during installation have been specified in the Kickstart file, then there should be no reason to prompt the user or prompt you for input. So our file system is being formatted. Keep in mind it's 40 gigs, but RAID partitions tend to format fast because the information is spread across multiple disks, in this case across 3 disks. So whenever the format or writes are taking place, the operating system quickly spreads the information to 3 disk heads as opposed to 1. And whenever operating with more disks, performance will always be faster, as you have more heads operating simultaneously, which explains why the 40 gigabyte space is being formatted so quickly. The install process is starting, and we should be off to the races momentarily. So again, just to recap, the way you take care of the RAID during installation is to clean your partition table slate unless you can't afford to lose information for another operating system, or you're upgrading from an older version of Red Hat or some other Linux variant and you can't afford to lose data, but you need to secure, in the case of RAID 5, at least 3 software RAID partitions of whatever size, as long as there's a common size. So let's say you need to allocate 20 gigabytes per disk, then secure that space, turn them into software RAID partitions. Once you have the 3 software RAID partitions, either on the same disk, which isn't recommended, or across multiple disks, then you create a RAID device. So it's software RAID partitions, then RAID device. Once you've got that first RAID device, which will be located beneath the dev tree as MD0, so /dev/MD0, then you can overlay a file system mount point, and you do so by allocating a mount point such as root, boot. In the case of boot, however, it must be on a RAID 1 volume, so it'll be root or var or home, opt, etc. And once you've got that in place and you've created your swap partition as well as your boot partition or your boot mount point, you can then move on with the installation. Optionally, you can RAID everything. You can create 2 software RAID partitions of a small size of 100 megabytes each, create a RAID 1 set, a mirrored set, and that'll be device MD0, for example. So dev MD0 could be 2 software RAID partitions of 100 megabytes each, which means you'll ultimately have 100 megabytes, but it will be RAIDed at least, and they'll be mirrored. Then create a second RAID set, which will be labeled or listed as dev MD1, make that RAID 5, and then associate the different mount points to different chunks of dev MD1. And then you'll be up and running once installation proceeds. So we'll let this elapse and pop in momentarily to see where we are, and then finish up the installation. And now we're finishing up the installation. So most of the files have been copied. The bootloader is being installed. And now we're ready to reboot the system and peruse the software RAID configuration. And now we're rebooting, and we should be up to the start menu momentarily after the hard drives have been detected. We'll just ensure that the boot ISO CD has been ejected from the server, otherwise it'll cause it to boot, unless of course we disable the booting of the CD-ROM. Reorder it, of course. That's an option. Now the disk drive backplane is being searched, and whatever is found will be detected and reported. Pixie boot. Here's the primary boot menu, the grub menu, and as we've done before with respect to the grub password, in order to make changes we have to press P to indicate the password, and then the proper password, which will allow us to make changes. Otherwise, it won't allow us to make changes. Now we'll edit again, just to avoid the whole startup routine having to fill out the forms. We'll edit the kernel startup by using the E option and indicating single. The kernel reads all of the options that you see here, including the location of the kernel, where the root device is located on dev MD0, with other settings. We'll press enter, then B to boot. It will be up in single user mode momentarily. And now we're booting. Universal device or UDEV is being started. And now we're in single user mode. This is the shell for single user mode, sh-version. So we're in, we can interact, and the key thing is to take a look at the partition layout. We'll clear screen and then execute a df-h. -h returns the output in human readable format. And there you see the root partition, / is assigned to dev MD0, which is the RAID partition. It's almost 40 gigabytes, of which 1.9 gigabytes are in use. 35 is free. 35 gigabytes are free. And SDA1 is assigned to boot, so it's independent. An LSL of dev MD0 will reveal the dev entry. Dev MD1 reveals no such entry because we didn't create another entry. And of course, the utilities, once you're up and running, can manipulate the RAID layout. We'll look at those later on when we make use of some of the space that's available. But we're up with the RAID5 configuration, albeit with a large partition root. Next, we're going to look at LVM, Logical Volume Management, during installation. So let's go ahead and reboot the system.